In this tutorial, we will learn the basics of machine learning algorithms and how they are used to extract patterns from data and make predictions. Machine learning is a branch of artificial intelligence that identifies patterns in data and maps them to desired outcomes, transforming raw data into actionable intelligence. A typical machine learning system consists of three main components: input, model, and output. The input is the data provided to the system. The model learns patterns and relationships from that data, and the output is the prediction or decision generated by the model. In supervised learning, the model is trained using labeled data, where each input is paired with a correct output, enabling it to make accurate predictions on new data. Deep learning, a subset of supervised learning, uses multi-layer neural networks to automatically extract complex features from large datasets. In contrast, unsupervised learning works with unlabeled data, allowing the model to discover hidden structures, patterns, or groupings without predefined categories. Regression is a supervised machine learning technique used to predict continuous values and identify trends or relationships between variables. It extracts the underlying signal from noisy data by fitting a line or curve that best represents the overall pattern. In linear regression, the model determines the line of best fit by minimizing the distances, known as residuals, between the observed data points and the predicted values on the line. This process, called least squares, minimizes the sum of the squared residuals, resulting in the most accurate prediction of the relationship between the input variables and the target variable. Regression is widely used for forecasting, trend analysis, and predicting continuous outcomes such as house prices, sales, or temperature. Logistic regression is a supervised machine learning algorithm used for binary classification, where the outcome consists of two mutually exclusive categories, such as churn or stay, spam or not spam, or yes or no. Unlike linear regression, logistic regression predicts the probability that an input belongs to a particular class. It uses the sigmoid logistic function, which maps the model's output to a probability value between 0 and 1. A classification threshold, commonly 0.5, is then applied. If the predicted probability is greater than or equal to the threshold, the input is classified as one class, 1, otherwise, it is classified as the other class, 0. This makes logistic regression effective for solving binary classification problems in machine learning. Support vector machine, SVM, is a supervised machine learning algorithm used for classification tasks. Its main objective is to maximize the classification margin by finding the widest possible gap between different classes. SVM identifies the optimal decision boundary, hyperplane, by placing it midway between the support vectors, which are the closest data points from each class. This maximum margin approach creates a safety buffer between the classes, making the classifier more robust to noise and improving its ability to generalize to unseen data. In a two-dimensional feature space, such as feature 1 and feature 2, SVM separates the data into distinct classes by drawing the optimal boundary with the largest possible margin between them. Decision trees are supervised machine learning algorithms that classify data by splitting it into smaller subsets using simple logical rules. They mimic human decision-making by breaking complex problems into a sequence of straightforward yes or no questions. Using a recursive partitioning algorithm, the model repeatedly divides the dataset into subsets based on the feature that best separates the data, continuing until it reaches a final decision or leaf node. For example, a decision tree may first ask, is the customer's age greater than 30? If the answer is yes, it may then ask, does the customer have a high income? Customers with high income may be classified as premium plan, while others are assigned to the standard plan. Similarly, the tree can classify customers as low risk or high risk based on the sequence of decisions. This step-by-step structure makes decision trees easy to interpret and effective for both classification and prediction tasks. Random forest is an ensemble machine learning algorithm that improves prediction accuracy by combining the outputs of multiple decision trees. Instead of relying on a single tree, it builds many trees using random subsets of the training data and random subsets of features. Each tree makes its own prediction, and the final result is determined by majority voting for classification problems or averaging for regression problems. This diversity among the trees reduces overfitting, increases stability, and improves the model's ability to generalize to new data. For example, When classifying an input as yes or no, a single decision tree might produce an error rate of 18% because it relies on one decision structure. In contrast, a random forest combines the predictions of many trees through majority voting, reducing the error rate to around 9% and producing a more accurate and reliable prediction. Deep learning is a subset of machine learning that uses artificial neural networks with multiple layers to automatically extract meaningful features from raw data. Similar to the way the human brain processes information, deep learning models learn hierarchical representations, where each layer transforms and refines the input by filtering out noise and identifying increasingly complex patterns. For example, in image recognition, the first layers detect simple features such as edges and colors. Intermediate layers recognize shapes and textures, and deeper layers combine these features to identify complex objects such as faces, vehicles, or animals. This ability to learn features directly from raw data makes deep learning highly effective for tasks such as image classification, speech recognition, and natural language processing. Unsupervised learning is a type of machine learning that discovers hidden patterns, structures, and relationships in data without using labeled examples. Instead of learning from predefined outputs, the algorithm analyzes the similarities and differences between data points to identify natural groupings or clusters. By measuring the similarity or proximity between observations, unsupervised learning reveals the underlying structure of raw data, making it useful for tasks such as customer segmentation, anomaly detection, and pattern discovery. This approach helps uncover meaningful insights that may not be apparent from the data alone. A common unsupervised learning algorithm is k-means clustering, which partitions data into k clusters by assigning each data point to the nearest centroid, cluster center. The algorithm repeatedly updates the centroids until the clusters become stable, grouping similar observations together. Another widely used technique is principal component analysis, PCA, which reduces the dimensionality of large datasets by transforming the original variables into a smaller set of principal components. These components retain most of the important information while simplifying the data, reducing noise, and making visualization and analysis more efficient. You have now completed this tutorial and are ready to apply what you have learned to real-world problems.